Oh shit. It's sweaty.
What is up, chemistry gurus? Today, we're going to be talking about the chemistry of fireworks. Today, we will learn about the explosion of fireworks, the propulsion of fireworks, the shape of different fireworks, and the color of different fireworks. But first, how were fireworks created? The first firework was invented around 800 AD. An alchemist mixed sulfur, charcoal, and potassium nitrate, a food preservative, hoping to find the secret to eternal life. Instead, the mixture caught on fire and gunpowder was born. The idea of fireworks was later fully fleshed out in 9th century China as a festive way to scare off evil spirits. Original ingredients of fireworks included salt, pepper, sulfur, and charcoal. This flaky, black powder is an ancient form of gunpowder. Fireworks were later adapted to be used in important events such as military victories, religious events, or royal celebrations. One of the most famous firework displays is the 4th of July. Although John Quincy Adams predicted the wrong day and referred to the fireworks as illuminations, 4th of July celebrates the freedom and independence of the Americans. Now here's a quote by John Quincy Adams.
The 2nd day of July, 1776, will be the most memorable epoch in the history of America. I am apt to believe that it will be celebrated by succeeding generations as the great anniversary festival. It ought to be commemorated as the day of deliverance, by solemn acts of devotion to God. It ought to be solemnized with pomp and parade, with shows, games, sports, guns, bells, bonfires, and illuminations, from one end of this continent to the other, from this time forward forevermore. John Quincy Adams. Now to get into fireworks today. Most fireworks have three main components: a fuse, a lift charge, and a burst charge. However, non-airborne fireworks may either have no lift charge or a separate charge to cause them to spin or perform other tricks.
So how do fireworks actually work? A fuse is lit from the exterior that runs to a reserve of gunpowder inside the firework. This is called the lift charge. It then launches into the sky while the fuse continues to burn, providing thrust. Then, the large mass of gunpowder is lit, exploding the construct. Fuses consist of a core of black powder and can have one or more textile overwraps. The outer layers may be coated with wax or nitrocellulose lacquer for water resistance.
To go into more detail on that, potassium nitrate is the main component in gunpowder. In airborne fireworks, there are two different types of charges, a lift charge and a blast charge. The lift charge is the first to be lit. The massive and sudden change in both heat and pressure within the shell causes the construct to take off from the ground. Once in the air, the fuse keeps running to the blast charge, which explodes the construct. In some fireworks, different shapes can be made by having separate blast charges encased in thin layers of tar. The tar will melt as the fuse reaches them and then explode the other blast charges.
Now, here are two different demonstrations on two different styles of propulsion. When fireworks were originally used in the 9th century, there was only one color, orange. This was the only color you would see in fireworks until much later. In fact, if you were there for the very first July 4th celebration, you would still not witness color in fireworks. This would not come for about another half century in the 1830s when Italian scientists began adding metal salts, as seen to the left, to the fireworks. And now here's a video on the style, color, and sparks created by a firework.
Now to perform a color experiment, what you're going to need is a Bunsen burner or any controlled flame,
Disclaimer: campfires and bonfires are not controlled flames.
a set of chloride solutions such as sodium, lithium, barium, strontium, calcium, or potassium chloride, or in a squirt bottle or a stick soaked in the solution. Now to perform this, you're going to want to do all your material prep before lighting the Bunsen burner. Using a squirt bottle or the stick soaked in the solution, shoot the solutions into the flame. Observe any color change and then after, clean up.
What is that?
This is so grainy.
Potassium chloride. Next one. Barium chloride. Next chemical. Strontium chloride. Next chemical. Calcium chloride.
Now the reason these different metal salts cause the flame to turn different colors is because of the emission spectrum of chemicals. As atoms make transitions from high energy states to low energy states, they give off electromagnetic radiation. This occurs in different frequencies. Different elements give off different frequencies. This is observable through the various assortment of colors that they appear to burn off when ignited in compounds such as strontium chloride, which burns as a nice crimson red.
The results for the flame test are as follows. Strontium produces a crimson color when burned. Copper produces more of a green-bluish color. Lithium is a deep pink or a dark red. Barium is a pale yellow-greenish color. Calcium is a standard orange. Potassium is a light purple. And magnesium and iron, when burned, produce sparks. The largest single-shell firework weighs about 2,397 pounds. And now, here's a video.
In conclusion, today we have learned about the history of fireworks, how gunpowder is used in a firework, how fireworks shoot into the air before they explode, how fireworks explode in different shapes, and how fireworks explode in different colors and sparks due to the emission spectrum.